thank you for your waiting. Let's start a few minutes. We have only 3 students. Okay. Okay. The first, I want to inform you that topic for today will be linked with the enzyme, and mostly it will be connected with enzyme dynamic. Yeah, because it will be important for us. And also we will talk about some specific type of enzymes. For example, regulation of enzyme. Yeah. Sorry, it's finished for check attendance for today, and let's start talking about our topic, because our topic link with some points around enzyme. I will show you now a presentation, and for example, it will be this one. Okay. And when we're talking about enzyme dynamic and we're talking about enzyme activity affected with some specific properties of enzyme. For example, we can talk about specific temperature. As you remember, enzymatic reaction path looks like, for example, if we organize some experiments with division of, just a second. If we organize some experiments with the division of proteins without enzyme, it will be necessary strong acid condition, yeah? Some highest temperature, and finally we will see that our situation will be connected with the process of, for example, digestion. But if we're talking about enzyme can organize this process in the, for example, other condition, in the more not so aggressive condition. Okay, let's come back to our topic, sorry. And also, for example, specific temperature, if we're talking about enzymatic reaction, this temperature not necessary. It will be connect with, for example, it will be connect with, for example, temperature of human body, because all enzyme will be work in the human body. Yeah, and when we're talking about, for example, microorganisms like bacteria, which will live in the high temperature condition, it will be connect with some enzyme will be working in the more highest temperature, like for example, more high temperature will be connected with the enzyme, because these microorganisms live in the a high temperature condition. And same situation with the pH. For example, we have microorganisms who live with acidic pH, we have acidic base, we have microorganisms who live in the for example, other base, like alkali base, and enzyme will be work in this concrete condition. Here you can see some enzyme from the human body. You see these microorganisms will be this enzyme, for example, pepsin, will be work in the more acidic condition. And if you're talking about trypsin, this chemical compound will be connect with this enzyme will be work in the base condition, base environment. Yeah. When we're talking about some principal way of the regulation of enzymes, we must talk about, for example, competitive inhibition, allosteric inhibition, allosteric activation, and covalent modification. What's mean all of this? Let's see. For example, when we're talking about regulation, okay, before talking about different type of the enzymes, let's talking about regulation. Some enzymes have a negative regulation. Yes, and this negative regulation will be negative feedback regulation. For example, final product can be blocked some stages of the first stages of the reaction. Yeah, and when we're talking about some other compounds, for example, when we're talking about it's an example how aspartate will be converted to the aspartyl phosphate, and aspartyl phosphate it will be second intermediate from the chemical reaction for produce some specific amino acids like lysine, methionine, isoleucine, yes, threonine, okay, and this enzyme will give possibility. This product, like lysine, will be regulate a process, will be have a negative feedback to regulate conversion aspartate to aspartyl phosphate. Yeah, you can see in this screen this situation. When we let's come back to the talking about type of the enzymes, like a competitive inhibition. It's specific inhibition when the process of, for example, some specific compound, which will be named inhibitor, looks or have some physical and chemical properties like same physical properties like a substrate. And it's give chance for this inhibitor easily to connect with the active site of enzyme. Yeah, because active site of enzyme will be blocked by inhibitor. For example, it's competition between substrate and inhibitor. Substrate and inhibitor. If you added in the solution more inhibitors, reaction will pass very slowly, and it will be the situation when in the solution enzyme will be more often meet with the inhibitor than meet with the substrate. If we change reverse situation, we can add it in the solution just some inhibitors volume, for example, a little bit, and enzyme will meet more often will meet with the substrate, but inhibitor also will play a role, and also a little bit decrease of velocity of the reaction. But it will be more intensive than when we're talking about inhibitor will be more volume, more mass of inhibitor will be more bigger than mass of substrate in the solution. If we added equally inhibitor and substrate in the solution with enzyme, it gives chance 50% of possibility of probability, 50% of probability will be to meet enzyme will be meet 50% probability with 50% probability inhibitor and with 50% probability substrate. Yeah, I think it's understandable. Okay, and what kind of also type of regulation we have? We have a specific allosteric inhibition. What's mean allosteric? Allosteric, it means allo, it's other, steric, it's a side. It means that inhibitor will meet with some other side, will be connected with some other side of, for example, enzyme. You see in the screen model of the enzyme with the substrate. It's just an enzyme substrate complex, but we have a specific zone in the enzyme which can be named allosteric regulation site, allosteric site, where allosteric inhibitor will be connect with enzyme and change conformation of enzyme, and enzyme will lose affinity to substrate. What's mean affinity? As you remember, affinity, it's just a specific properties of the enzyme to glue together substrate and enzyme. It looks like a magnetism, yeah, magnetism. Because magnetism, it's just a possibility to glue together two type of metals. Yeah, it's a little bit looks like this one because magnetism can be different, can be very strong, and have a very good connection between two metals. And magnetism can be very weak, and you can easily wrap these linkages between some specific metal and with some specific, for example, magnets. It's important. And like this situation, we can talk also about enzyme substrate. And for example, if we added allosteric inhibitor to enzyme, and enzyme lose possibility to connect to it's not react, it's just will be lose affinity with this compound, with this substrate. Okay, next. Allosteric inhibition. It's just repeat what we talked before. It's also we can talk about allosteric activation, because allosteric activation will be linked with the possibility of connect with the allosteric site some allosteric activator, and allosteric activator give us, okay, wait a second. Allosteric activation. Allosteric activation, it's a reverse situation, reverse scheme of the regulation which we have. And also, it's just repeat. And also we have a specific phosphorization of enzyme. It's just added phosphate and loose phosphate. We have a two enzyme which can added phosphate to the some enzyme and wrapped this phosphate. It's also important point of regulation of some enzymes. I think about these methods we will be talked a little bit more later in the next practicum class. For today, I think it will be enough. Yeah. And if you have, do you have a question?
No, sir.
No, sir. Thank you.
Okay. Have a nice day then today.
Okay. Goodbye, sir.
Good luck.
Okay.
Goodbye.